Okay, so looking at my drawing, you guys remember I skipped that sight glass, right? And well, it's coming up now because my sight glass really should be after that valve we just talked about. It's not always there, but sometimes it is. Here's what it looks like.
Whoa, what is that? Never seen it.
I know you've never seen one clean that you can actually look through and see the color and all that, right? That's
clean and
the factory picture. They don't really look like that.
I didn't know those
All
were.
right. Did you know that this dot in the middle here, this is our color indicator for moisture, okay? When I have moisture, that's gonna go towards yellow. Right? The farther towards yellow that goes, the more moisture I have in my system, right? That's a piece of paper. It's just a chemical treated piece of paper that reacts to water, right? When I pull a vacuum on a wet system, it will turn green. It will reactivate. It will go back and forth.
I've never seen it go back.
You pull a vacuum on that.
Until they won't, right? Until they don't anymore. Like you guys just said, I've never seen one go back. It's bad. It's expired, right? It's gone as many times as it can go. It's 23 years old. It needs to be replaced.
That or nobody wrapped it when they grazed it in and burned the sticker off.
May have been improper installation technique. Right, most of these were originally installed by the factory. Usually they're pretty decent when they come out from the factory. They just die over age,
Yeah.
right? Or a service tech is working around them and overheats or whatever, right? Did you know that's replaceable?
Yes.
That piece of paper is replaceable.
On
Yeah.
most of them.
6 hour cook time.
Yeah, up to 1 inch and 7/8. Once we go bigger than that, they're not.
Holy shit. That's big.
All right, this drawing shows the plug on the back that holds that cartridge in. That cartridge is what's holding our piece of paper. So if we have one that no longer responds, we don't have to replace the sight glass. If the glass is okay, which probably is, okay? Unless it's got oil running through it and it's stained. I just showed that I'm saying this should be in a different place. Well, here are the 3 locations we're gonna see this and what that means, all right? So the first location is coming out of the liquid receiver after my filter, okay? That's the first location. That's what the Sporlan drawing was showing when I showed you that diagram, right? That's where they showed that there, okay? Why did I say that's a bad place to put it? Well, it's pre-subcooling. So if I'm looking at it, right, first off, what's the sight glass for? What's the purpose? Well, the purpose is so we know we've got solid, column, and liquid going to our TXVs. That's the purpose, right? That's the reason why we look at it. All right, that and moisture to see if we have water, okay? So if I put it here in this top position, I haven't subcooled yet. What's the subcooling in my receiver?
0.
Yeah, it could be 0. Could I naturally have vapor in this liquid before I subcool it and everything be just fine?
Yeah.
Of course. It's useless right there. That's my point. If I have a mechanical subcooler, putting it there,
Does nothing for you.
I don't care.
Goofy.
I literally don't care, right? Because I'm about to subcool, and then I care, right? But I don't prior. We do have stores that are built this way. I don't know why. I don't know. I wish I could ask some of those guys. They're not around.
Extra
This
money
was-
in the budget.
They were building this stuff 40 years ago. Yes, sir.
So if you have it before your subcooler and you have your subcooler and your subcooler's working, could you just take the subcooling at your liquid header, and if you have your subcooling, then you know you've got solid column liquid?
No.
Why?
I like that idea.
That's why I was saying you can't do that.
All right, because if I'm flashing occasionally through that, my pipe will still be cold. I'll still read the temperature as if I'm subcooling, because I am subcooling sometimes, right? But when I'm flashing, it's coming and going, I won't see that. When I have 0 subcooling, my pipe will instantly warm back up. This was one of the challenges we were talking about with measuring superheat with a change in suction pressure. Our temperature doesn't move fast enough for us to read that because the copper pipe doesn't react as
So it'd
quick.
be the same.
Same problem on the other side, okay? Now, can you be fairly confident? I've got a lot of liquid, right? Maybe not 100%, but 90
55
something.
degrees of subcooling.
Yeah, yeah,
Then we're
yes,
probably
then
okay.
yes, it's gonna be pretty close, right? But I won't see that little bit of rivering, I won't see the flash that comes and goes, right?
Okay.
I just won't see it. All right, so, but I will here, okay? if I put it on the outlet of my subcooler after it's been subcooled, I'm gonna see it here, right? If I've got flashing going on here, that's the liquid I'm sending out to my store. That's a problem, okay? It's not a problem up here. In fact, it's meaningless and almost expected on a hot day, right? Whereas down here, if I'm flashing, I don't have enough liquid. I am subcooled, I've cooled it down, but I'm sucking more liquid out of the pipe than the pipe has. That's what that's telling me. It is subcooled, but it's
Just not.
separating, right? I'm starting to run out. Pipe's too big for the amount of refrigerant I'm moving.
Yeah.
I can't fill the pipe. That's what that means. It's a different problem.
So you could have a plugged liquid line, or you could have a large pressure drop across your liquid line filter dryer, still get subcooling out of your subcooler and
Yes.
flash inside glass.
Absolutely.
Yeah.
And that's exactly how it plays out.
Gotcha.
That's how we see it as
So-
technicians.
So if you see that sight glass flashing after your subcooler, go for that liquid line filter dryer.
Ding, ding, ding.
Go.
Right? I'm looking for a restriction between my sight glass and my receiver.
Right.
Hey,
No, I got one. I got a real common one.
So it's either that or you have 0% errors.
look at that.
Right. Or I'm actually flashing. Now, if I'm actually flashing because I don't have enough refrigerant, I can't subcool that. So then the third position I may find it is after this outlet pressure regulator. All right? If I have one. If I've got an LPR or OPR there, I may have a sight glass downstream of that. All right? The only difference between these two is this is a restriction, remember? So if I've got this set up, my sight glass should be here because this is flooding all the way to my liquid receiver. Well, what do you think my sight glass is gonna look like if I'm flooding?
Clear.
Full, even if I'm not, right? So this outlet pressure regulator could hide the fact I'm out of refrigerant or I've got a stopped up dryer
Well, empty.
if I'm looking at the sight glass here. So if we install one of these, we wanna put the sight glass downstream,
Gotcha.
okay?
So you want to put your sight glass as far downstream as possible.
Yeah, really.
As close as
Ideally, I'd have one in every case right at the TXV.
Right.
Really, on the other side of the strainer.
Oh, yeah.
Wouldn't that
and
be
suction
perfect?
ball valve at every case.
Yeah,
Yes.
yeah. It's not practical, but that would be awesome.
Okay.
That'd technically be the perfect place for them. You know, I kind of went by that very quickly. What does it mean? When I'll see different things in the sight glass. If I walk up to a sight glass and I see nothing at all,
It's so clear you can't.
is that good or bad?
It could be very good, could be very bad.
All right, it's either 100% great or 100% bad. Right? I probably check the case temp and I'll know which pretty quick.
Yeah.
Right? It means that I've got a full solid column of liquid, so I see nothing, right? Because refrigerant's not colored, it's not dyed, so we don't see it. Or it's completely empty, right? It's vapor. I just have vapor going by, no liquid, all right? One of those two scenarios. So the next scenario that I'm gonna have is a partial glass. We call it a partial glass. This is when I'm looking at the glass and the top, gravity, is gonna make vapor rise to the top if it's not a full solid column. I'll look at that thing and I'll see a line, okay? And that line could be near the top, it could be in the middle, it could be at the bottom, right? But I've got a line in the glass. Yes, sir?
So a vertical sight glass,
Yep.
no, horizontal.
You're gonna see on our systems, you're gonna see the sight glass like this.
I'm saying
Right, he's talking about mounting it this way or this way.
So horizontal ones, and you look down, and it just kind of looks like a little stream.
Right, so that's rivering, and that's the third thing I was gonna talk about, okay? So our sight glasses are supposed to all be turned this way, and we'll see that glass. It'll tell us what percentage of that pipe is full of liquid, right? 50%, halfway, okay? We want it to be 100. So anytime I see anything in that, if it's positioned in the right place, it's telling me I have a problem. If it's up here, it's meaningless, okay? But if it's down there, that's telling me I got a problem, right? And we just talked about that. Liquid line dryer is my most obvious potential issue.
High load.
On this setup, this guy could be restricting too much. If I flip my bypass on and it fills up,
Yep.
this guy's my problem. Right? Okay? Now, what we were just discussing is if we turn that sight glass this way, well now if I fill up 50%, what's that gonna look like? This is gonna look like a tornado. going through my sight glass. I'm gonna get the swirling bubbles. I'm gonna see the bubbles just kind of swirling as they go through. And I'll see that to about, when I lose about 25% to 30%, I'm gonna see that happen. When I lose more than that, when I lose 50% or less, what I'm actually gonna see is the vapor is taking up more space than the liquid. I'm gonna see the liquid moving around the vapor. This is the rivering idea, right? It's gonna look like, I'm gonna see liquid flowing through the glass. It's gonna be moving. Like, what in the world is that? Right, we call it rivering. Right, that's when I'm really running out of refrigerant. I don't have a lot, and that's when it's faced up. That's not nearly as clear as sideways, and that's why the spec for refrigeration is we always turn it sideways. The only time we don't turn it sideways is practically when we can't see it, if we do that. For instance, in a case, looking down inside a case, we turn that thing sideways, you'd have to put your phone in that nasty sludge and slime that they hadn't, because they hadn't cleaned that case in 2 years, right? But if we turn it up, we can see it real clear, right? So we will turn them up when practically we can't rotate it. But in our rack, we're gonna be able to rotate a lot.
Put it wherever you want.
You put an ID on it, it won't matter, you don't need to, just pressure
I
drop.
like my sight glasses upside down.
Kaiser, for whatever reason, Kaiser's got this thing with the way they built their racks, all their sight glasses face the same direction on the end. This is the rack that's in the middle. You know, when you walk in, you can get all the way around the rack, full-size rack house, but you can go all the way around the rack.
Yep.
It's always gonna be on the end near the subcooler, right?
Yep.
Well, if the rack went in, when you walk into a rack house, you got a rack on the right and the left. If it went in on the right, you'll be able to see the glass. If it was on the left, it's gonna be facing into the rack. So you're gonna need a mirror or your camera on your phone. You'll find the sight glass, you'll be looking right at the back of it. It's like, Jesus, who was the, right? It's because they just built them all the same, and they didn't tell that guy, hey, by the way, every other one you want to rotate.
5 for 15.
If it's A, it goes this way. If it's B, it goes this way. If it's C, it goes this way. If it's D, it goes this way. No, they're like, nah, all the same. Anybody have any questions about the sight glass? Pretty simple. Just want to cover those.
If you had a liquid line with 2 taps, and you were to put a flare liquid dryer on your hose, could you theoretically just like bridge the gap, and then you essentially have liquid line sight glass to gauge charge with? It's just kind of like a theory question, you know what I mean? Like if you have, let's say, a self-contained case or something like that.
Right. If you had a pressure tap on both sides.
Like if you had 2 liquid ports, right?
Right. Can you run a fight?
Theoretically, you could just put your hose on one side with a sight glass in the middle and your hoses, and then the other side.
Right.
It would be,
You mean like?
So you would have to valve off the pipe. It would have to have a valve in the middle that you can force the refrigerant through your rig. And your rig would have to be the correct size or larger than the pipe that you just valved off. In other words, you'd have to wire it
way
in
to crap on
series.
my dreams, Matthew.
All right, you have to plumb it in series instead of in parallel. You're thinking in parallel, but if it's in parallel, it's a resistance, so it's gonna take the path of least resistance. Your refrigerant's not gonna flow that way.
Yeah, I was just saying, like, yeah, that was my question. It's like, how accurate would it
If you
that?
put it on the bottom of the pipe, then it would just,
That's just gravity. It's always cool.
Path of least resistance. Pressure doesn't care that much about gravity. Only when everything's perfectly equal does gravity come into play, which is not very often. Okay, so let's talk about the next thing. So when we come through, we hit the liquid header. You know, we came out of that valve, we hit our liquid header. Our liquid header, right? Not hard enough to break it, just hit it. We hit our liquid line header. No sound effects that time? All right. And then our liquid line is we're going to be headed towards our EV. Before we get there, we're going to go through a mechanical ball valve, which I'm sorry I didn't do anything on.
Righty-tighty, loosey-goosey.
unless you go right.
And we're gonna hit a solenoid. All right. So there's not a ton of solenoids, but there are a few things that we want to be sure about. Okay. So not every single application is going to use a solenoid anymore. They did. Every single one used a liquid line solenoid. Well, now, these days, as we were just discussing earlier on the break, if we have a pulse valve as an expansion device, it can be the solenoid. It can work as the solenoid. So we may not. may not have a solenoid in that application, okay? It's possible we have an electronic expansion valve, EEV, that doesn't have a solenoid, depending on how critical that it is that it actually close. They don't tend to close 100% perfect every single time, but they close really close, right? So sometimes if it's not all that important, we may not have a liquid line solenoid valve. All of my mechanical stuff is all gonna seep. My TXVs are not gonna hold tight. They're definitely gonna seep. So I'm gonna have a liquid line solenoid, all right? In this setup, you can see my EPR is sitting right here in front. My liquid line solenoid is on the same circuit. It's on the other side, okay? That's what we're talking about. Now, yeah, you knew this was coming. You knew this was coming up.
Yeah.
All right. Liquid line solenoids are not sized by the size of the pipe.
Say it louder.
Say it for the people in the back.
Dang it. All right, they're not. Okay,
Says right on mine.
so there's a couple things. You remember when we were talking about pi valves or A8 valves, A9 valves, I gave you those numbers. 17 means 17/8 of an inch, right? Well, we're gonna do the same thing with solenoids. Solenoids are gonna be sized to match our BTU loads, and they're gonna have different size holes, orifices, right? The orifice, the number of the valve is equal to a 64th of an inch. And maybe 30 seconds. It's a 30 second, I'm sorry. It's a 30 seconds, 32nd of an inch, right? So if I say I've got a 7, right, it's 7/30 seconds.
Oh,
Didn't know that?
nope.
So, but now it's starting to click in your head. If I've got a 3/8 valve, and let's look, I got a 3/8 valve here that's got a port size that's .001, whatever. That's too small. Let's move up to something we actually would use. Here's one. Here's a 3/8 valve that's got a 3/16 openage. Okay, that number is 6/30 seconds. Right? Does that make sense?
That's what it ends.
If I go to another 3/8 valve, here's another one down here. It's a 9, right? 9/30 seconds.
So you can make a 6, a 9 with a
Is it
9/32 drill bit.
Oh, yeah.
No, you cannot.
But no, he was right.
No, you cannot.
Oh, he's wrong.
A little more complex than that, but the size is correct, right? Your distributor, you're thinking distributor. We'll get there.
We can give it.
All right. So anyway, so just know that I can buy the right size copper and have the wrong size valve. Okay? So I'm going to use this chart. This chart is the one, this is a Sporlan's chart, on how to figure out which valve is the correct valve. Right? If I get a pressure drop across all these, right? And I can have a severe pressure drop across these.
Yes.
That's why remember that E42 valve I showed you? I made a big deal about it has no pressure drop. It's because these have a big pressure drop. Okay? Now it's usually liquid, so we don't care.
Yeah.
It's on the liquid side, right? Usually. Okay, until I start controlling that liquid pressure very precisely. Now, if I've got the wrong size solenoid, I could have a problem, right? Because I'm supposed to have 100 pounds differential across my suction discharge in the valve, but if I'm knocking 20 of it down by having the wrong solenoid, I only got 80. Uh-oh,
Yeah.
that circuit's running
No
warm,
bueno.
right? Okay, so this is gonna give me a couple things. One, I've got different refrigerants, so I've got to find my refrigerant. Notice there's no 449 on here.
Thank God.
There's no 448A, right? So I'm gonna have to, with these modern refrigerants, I'm gonna have to look up the most current version or whatever. This book that I've got this cannot be more than 3 or 4 years old. It's not that old, and it doesn't have these new refrigerants on it. So as they change, you have to update that. All right.
You can kind of just use R22.
So you can, it's not, it doesn't have to be exact. Here's the thing. If I say I need a 1.5 ton valve, right? It doesn't mean 1.5, okay? That means 1.6, 1.4, somewhere in there. That's okay. I'm gonna get close, right? When it comes to solenoids, they're one of our least critically sized pieces. I could be off by a significant amount, and this will still work, okay? If I go too big, my pressure drop goes way down. This sounds great. except the solenoid works on that pressure difference. So that means if I go too big, I won't have enough pressure difference, the valve just won't reliably close. It may close 9 out of 10 times.
And that one time you're getting a service call.
Yes, sir.
I remember that valve Nathan said to get the E5. I ended up getting the E14.
And this is why we changed so many of them this year.
All right, okay. So startup guys, I cannot overstress how important it is that you guys check this. Because like he just said, we changed a lot of solenoids on cases that would not make VPR because they had a 3/8, going to a 3/8, gotta be good,
Yep.
right? And it wasn't. If they're too small, I told you, if they're too big, the valve won't reliably close, right? Well, what's that gonna look like on an RCU?
A ton.
Iced up evaporator. I'm gonna ice up that case because it's only defrosting 9 out of 10 times, or 8 out of 10 times, right? It's gonna skip some defrost, okay? It's gonna open in the middle of a defrost, right? Because the pressure differential isn't great enough. So if I go too small, my pressure differential is skyrocketing, right? That means the pressure across that valve, the TXV itself, is going down, right? We just talked about that, makes the valve smaller. So now I'm starving all the time, I can't make superheat, right? Because it's too small. So I'm going to size it appropriately, and I'm going to do that. There's a couple best practices, I guess is the word I'm looking for here, okay? Now, my pressure drop on this chart, you can see my refrigerant type, I've got 1 to 5 PSI. Does that mean I cannot have a pressure drop higher than 5 pounds?
No.
No, that means if I have more than 5, this valve is not suitable. Okay? It's the wrong valve. Right? Can I have a pressure drop lower than a 1? Yeah. Once again, it's not suitable. The valve will not work correctly. Okay? So that's why I've only got 1 through 5 PSI. All right, there's two components to this I want to be sure you guys understand, all right? The first one is I can have a valve that works on 2 different settings. And if I look at this example, right? Let's say I had a 3.8 ton requirement. This valve works, right? It has a 3.8 and it's got a 4 pound pressure drop. 3.8 over here is going to be about 1.5. They'll both work, all right? In that scenario, both valves, I can choose either one, all right? That's what this chart tells me. If I go to 4, I got 4. This one actually works. It's on the edge, right? But it does work, okay? But if I go to 2.7, that's going to be less than a pound over here. This valve's too big, all right? So I've got to use this one. All right, now that's using this chart and this tonnage exactly as printed, which is probably what you guys have been doing. I'm about to ruin that for you. I'm terribly sorry. All right? Oh, I blew all that up so you guys didn't have to stare at that little tiny number. Sorry. And I did not blow up the part I wanted to discover here. Down here underneath this, refrigerant liquid temperature correction factors.
Oh,
Son of a...
yeah, we should have just cropped that one right out.
All right. We're going to see this chart over and over and over, and I do have blown up in another portion. We'll go through it deeper. But what I want you to understand is by subcooling our liquid, we change the tonnage of our valves. Because remember, when we remove heat from our refrigerant is more effective. We need less of it to do the same amount of work. All right, all this is making sense. You're going to hear this over and over because it's really important on all of the sizing issues we have. So in this example, guess what? 100-degree refrigerant has a correction factor of 1. It doesn't change anything. This is all designed at 100-degree liquid. Well, for subcooling at 50,
80.
let's see what that does. 1.49, 1.5 is our correction factor. That means we multiply this tonnage by 1.5. Oh,
Oh, that's a big increase.
that just changed some things,
That did.
right? Right. So that means this very valve that we were sitting here saying is a 3.3 ton valve.
Not anymore.
So do we get your calculator out? 3.3 times 1.5.
5.7.
5.7 tons. All right. So this little valve here that we were looking at going, I got a 3-ton system, right? Is this valve gonna work? No. Yeah, the chart said it would until I took into account my subcooling.
You add or multiply.
You multiply
Multiply.
That's what I just did.
3.5
1.5 times 3.4?
3.3
Oh, 3.3. Okay.
is 4.9.
Yeah, I was off.
That's what I guessed.
You got four and a little bit?
4.9.
4.9.
4.9, 5-ton valve.
Yeah, five-ton valve.
All right, so that 3-ton valve that we were looking at, we got a 3-ton load, and I'm trying to match my 3-ton valve. I've actually just matched it to a 5-ton valve. That's not what I got. I actually have 3 tons. So I've got it, now I've got to recalculate all of that, right? If I don't account for my subcooler here, I'm gonna pick the wrong valve. Now, here's the other bit.
What?
My engineer, when he designed my rack, accounted for my subcooler. Yeah, that's right. If I turn off my subcooler, they don't have the right solenoids. So not only does it impact everything else I talked about, it's even turning on and off the case is now impacted, right? Could I be starving? Now, if all of a sudden this thing, I thought I had a 5-ton valve in here, and now it's only a 3-ton, right? That's gonna create a pressure differential, a giant one,
And you're gonna lose
right?
capacity.
Could that affect my superheat?
Oh, yeah.
Yeah, it will. There's a second factor why if I adjust a TXV with my subcooler off, I'm screwed.
So note this.
Right, there's a second reason.
Cooler doesn't work, you're fine.
I may have a 60-pound differential across that valve because I got a 30-pound differential at my TXV, or my solenoid, because my solenoid is massively undersized because it's now getting 100-degree liquid and it was designed to run 40 degrees.
Wow, so I wonder.
How many things you've misdiagnosed in your life?
I don't even wonder about that. Typically, I already know. But, no, I'm gonna go, yeah, I'll get a call.
How many folks have seen this before?
I can't
I
see that picture.
couldn't see what it is.
Yes.
This is a specific customer's version of what they call parameters.
Yes.
All right?
What you sent me, or?
Sorry, I need that.
All right, so what we got going on here? So this is on the library. You guys, it is on the supermarket library. You can download this and use this as a tool for any customer, right? What this is a list of model numbers on the left-hand side of every case that this customer has ever purchased, right? Yes, sir.
Just quick, those cases we were talking about the other day aren't on there.
Right. It is updated periodically, and our business is installing their brand new stuff. So sometimes the newest cases are not on here, right? Well, not sometimes, every time, the newest case won't be on here. But they will update them, they'll be in here. So for service, very useful. For design, sorry, you guys are startup, you guys gotta go blueprints, okay? But what we're gonna get here, there's gonna be a lot of information here that's really useful. It's gonna give us how many defrosts a day the owner wants, but it's also gonna list the manufacturer setting. So when we're at a different customer and we're trying to look up the spec from, what does the manufacturer say? Well, it's on this sheet, right? They say this is what Kaiser wants to do, and then it says this is what Walmart wants to do. And we can see if it's different or the same, okay? And when we're in a Walmart, obviously, we're gonna go by Walmart settings. When we're not, we can go by the other. It's gonna give us, anyway, it's gonna give us our defrost termination temps, it's gonna give us how many a day, that's gonna give us how many minutes, it's gonna give us CFM on fans, how much air should we have coming out of the honeycomb, it's gonna give us the TD across the evaporators, is this 6 degree, 10 degree, whatever that is, it's gonna give it to us. It's gonna give us superheat on anything that's not the standard 6 to 8 or 8 to 10. And we'll talk about that when we get to the valves a little bit. But if we've got a superheat that's 4 or 2 or something weird, it's gonna be on this sheet, right? But the reason why it's here on solenoids are cut in, cut out, right? And that's the part that I blew up here. So let's talk about that, the cut in, cut out strategy, the way that this works. And this particular customer's not the only one that uses this. This is the way it's always been until recently, okay? The manufacturer's target temperature, right? The manufacturer's gonna say what this case is supposed to run at, right? Well, we're gonna take that and we're gonna add 2 degrees and subtract 2 degrees. If my case gets down to my cutout, in this case 31 is the target, right? 2 degrees under that, 29, I'm gonna close that liquid line solenoid. I'm gonna shut off refrigeration to my case. It's got too cold, okay? And it's gonna stay off until I hit my cut in, 2 degrees above that target, 33 degrees. That solenoid's gonna kick on, right? And I'm gonna refrigerate again. This sounds a lot like Tech Assist, doesn't it? Like the perfect range of Tech Assist? It is. If we open up our EPR and we let the system run on the cut-in, cut-out, we're gonna score 100% on Tech Assist.
So,
Oh, really?
Run
Well,
the
that
EPR
sounds like
wide
the
open?
thing to be doing, doesn't it?
now let the solenoid do the work.
You fuck your rack.
All right. We're gonna get 100 on Tech Assist right up until we can't make suction pressure anymore on the whole rack because we've destroyed all of our compressors, right? That's what's gonna happen. Why is that gonna happen?
Because we're not trained.
Because somebody set the EPR wrong.
Okay, because we just said opening the EPR causes this to happen. What's bad about opening an EPR?
Cycling, mechanical cycling.
Mechanical cycling. Mechanical cycling of my case is gonna cause what?
Load issues on your
You
rack.
wanted a quiz, here it is.
And
All right.
Corey's idea.
No, it wasn't?
All right, Corey's got it. Corey, shut up. All right, so, because he's got it. All right, turning my case on and off is gonna cause what problem? It's gonna impact my compressors.
Julian,
Repeat that again?
Yo,
What was the question?
All right, if I open my EPR 100% and I let this cut in, cut out take effect, what impact am I gonna have on my compressors? How's that gonna impact my compressors?
Suction pressure, you know.
Suction pressure, up and down. Suction pressure going up and down because I'm changing my load. What's gonna happen because, now you be quiet, my suction pressure is going up and down, what's that gonna cause?
RJ.
What?
Compressor, mechanical.
Compressors are gonna cycle. Turning my compressors on and off are the worst thing I can ever do to a compressor, right?
only apprentices talking now.
So, that's not refrigeration related, but things that run are made to be on and off, but they're making cars, when you stop at a red light, the engine shuts.
Yeah, it's horrible for your car. That's the worst thing you can do. Ask your mechanic, should I bypass that?
Absolutely.
He'll be like, done, right? It's illegal, okay, because the government's requiring it for fuel savings. Is it costing you the life of your engine? Yes, absolutely. There's no way it's not.
You're in the drive-through, you're in the
Yeah,
board.
right.
No, you just unload
Sure.
a few cylinders while you idle. That's all. You turn a V8 to a V4.
Right. We know how to do this, right? Yeah, just unload. What are you doing? Don't shut it off. Just unload it,
The mechanics are tired.
right?
They are.
Okay, all right. So starting and stopping our compressors is bad for them, all right? But what else is that impacting? That swing in suction pressure.
Money.
What else? All right? Suction's going up and down. It's causing my compressors to turn on and off. What else is impacted by my suction going all over the place?
Case temperatures.
Back.
You said how
Where's last one?
Compressor amps.
Overall saturation.
Compressor amps, but that's not what I'm getting at.
Overall saturation.
How about my oil system? Does it care?
Oh, yeah.
Ah, yes, sir.
What's going on?
And on the OCV.
OCV is referencing my suction. Yeah, I'm gonna start running out of oil. Is running out of oil good for compressors?
No.
How long will a compressor run with no oil with a mechanical oil safety on it?
Depends on which one.
That's exactly right. POE, since you're having me designate,
120 seconds.
2 minutes. Do you think running that compressor with no oil for 2 minutes is shortening its life?
Oh, yeah.
No?
just a little.
It's only
Just a little, just a little.
Just a wee little hot.
Ow, ow, that hurts. That hurts, physically hurts me. I don't even like thinking about it.
10 years off your life.
But here it is, right? Here's my cut-in, cut-out. Walmart's encouraging us to even do this, right? By giving us that goal of 100%. If we open our EPR, we'll achieve it. Right? Short term, okay? Yeah, causing all this cycle. All right, so how do we manage that, right? We're gonna go to this manufacturer's target. This is what we're gonna target. We're gonna set our EPR to that, right? Not that.
Yes.
This is a safety. This cutout is a safety so we don't freeze our product or we don't damage our product, right? That's what it is. It's a safety device. If we're running on the safety, that's a problem. If we walk into a rack and the low pressure switch is the only reason the compressors are stopping, or we're like, well, that's cool, it's working.
It's cycling.
Right. Well, that's what we're doing when we're cutting in and out. We're doing the same thing.
Product is cold, HH.
Hello. Anybody got any questions about liquid solenoids? Like I said, there's not a ton to them. The key here is, startup guys, validate the correct one is installed. Use that chart and your liquid correction factor and make sure that that tonnage is in the ballpark, right? Because the ones we've been changing ain't in the ballpark. They're not in the ballpark. That number is your 30 seconds of an inch, right? You don't have to memorize every one, but now you understand a step from 6 to 9 is 3 30 versus a step from 5 to 14. What was it? Right?
So, when sizing a liquid line solenoid, and I know that you don't want to go too big, but in the case of you're really, really close, you would just go to whichever size you're closer to, right?
Yeah, so the perfect design, if they made an infinite number of sizes and I could pick one, would have a 3-pound drop. Right? That's the perfect size. 1 is my minimum, 5 is my maximum, 3 is right in the middle.
3's a good size.
Right? So the closer to 3 I can get, the better. There you go. Okay. Will it work at 2? Yeah, it'll work. Will it work at 4? Yeah.
It's about average.
Yes, sir.
So with that tonnage, I'm taking the tonnage off of the, like TXV, like the cartridge size, is that what I'm basing?
I'm getting the tonnage off of this. I'm getting the tonnage off of this chart. Right? This is my tons. Okay? So when I'm looking at the model number of my valve, it's telling me with this refrigerant and no correction for my liquid at 100-degree liquid, that's a 3.3 ton valve. It's going to have a 3 PSI drop.
Yeah, the number 1 through 5 is the pressure drop.
So,
Right? So I look at my BTU load, right? I look at the BTU load for that circuit. It's going to be on my legend, right? And that's the number that I'm looking for. Let's say it comes out to be 2.7. I'll look at this chart, it'll be 2.7. I got a 2.7 here, and I don't even have one here. This is the only valve I can choose. Right? Now I've got to plug my correction factor in, right?
Not
That's
for
how I use that
RCUs,
chart.
This is only on racks. Okay.
Do it?
Not for RCUs, this is only on racks.
Not for RTUs
correct, but for RCUs, you do need.
or RCUs. So my RCU, my RCU in Florida, that liquid temperature is probably designed at 95,
Yes.
right? Until we get down towards Miami, it's 100 down there, and then once we cross I-10 going north, it's going to drop to 90 somewhere in Georgia. I don't know where that is, but anyway, for us that's about 95 degrees. Well, this correction factor is 1 at 100. You can pretty much just read the chart.
Right. With the RCUs like grab and goes, you're gonna take, since there's no rack legend telling you what it is, you're either gonna look at your print or take the data tag off the case, add up your BTUs, and then compare that to your chart.
Or pull up your blueprints, which will also.
Yeah,
Right.
he said,
Pull up Trello and tell.
don't
me
go off the
that's
condenser.
good.
Yes.
Right, that's correct. Now, what they're talking about are RCU sizing, okay? My condenser and my evaporators are sized independent of each other.
Yes.
Right? They should be close. They should have enough condenser to cover my evaporator, not the other way around. The condenser should be larger, right? But I do want to size my load on the evaporators, not the condenser.
Correct.
Right.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. Vortex by Tex.